Hello everyone. Hope you had a nice lunch, and to those of you who have joined online, welcome. We will just give it a few moments because people are still digesting and returning from their lunch, but we'll start in a few moments. It's now a few minutes past the starting time, so I think I just slowly start this session. And now I actually got the clicker to work. I think I do. Let me try again. This was an issue before the break, but I thought, yeah, now it works. And how can I go back? So now I can stand up. Yeah. They're doing it. Should I say something? Does it work? Okay, so I want to stand up this time. Okay, so in this session we're talking about SNOMED and the information model. So for those of you who are at the introduction, everything focused on SNOMED and its role in supporting high quality clinical clinical data. So this time we're diving more into the implementation side of things, talking about how SNOMED works in conjunction with information models. I told also in the first session that SNOMED is just part of a puzzle, and that aspect will become a lot more clear in this session. So I will repeat for those who weren't here in the first session that I'm Højen, and I'm a part of the implementation support team at SNOMED International. I worked closely together with Alejandro, who's there. He will be doing the main talk in the next session, where we'll talk about data exchange, but may also have a few clever remarks to supply. So you will also hear from him. And we also have a third colleague in our team, which is Kai Cooley, and he's also around. So also have an opportunity to go and say hi to him. So what we'll be covering in this session is, first I will talk about what terminology binding is. Terminology binding is a term that you will hear many times when you work within health informatics and within terminology and information models. You'll hear about terminology binding. So for those of you who are not familiar with this term, I will really make that very clear in this first part. I'll also talk about why it's important and why it can be challenging. Then we'll dive into some principles for terminology binding, so to help those involved, and those involved are often people involved in the implementation and configuration of systems. We'll talk about general principles, some of the means through subsets and value sets, expression constraints, and then we'll also reflect a bit on how terminology binding aligns with the SNOMED concept model. And at the end, we'll show you some examples and demonstrations. Yeah, it is a mouthful, it's a lot, but we'll see how far we come. So what is terminology binding? So as a binding between terminology is of course the linkage between the terminology and the information model. So in order to understand the role of terminology binding and what it is, you need to understand those two parts, those two elements. So I'll first very briefly talk about the terminology part, the information model part, and then we will look at the binding part. So when you implement health IT, you have many anticipated benefits about what IT can do for the healthcare. We have so many goals we want to achieve, and if we just have IT and clinical data, we hope to get there, such as increased efficiency and accuracy, improved data accessibility, data sharing, and down to we can have more accurate and increased billing accuracy and revenue, and we can improve documentation accuracy and completeness. There are so many things benefits we want to achieve, but how can that be obtained? It's not the terminology alone, it's not the health IT systems alone that does it. It's really a thorough planning and a careful implementation. So the solution is not just introducing IT, like plugging electricity to a piece of paper, and then you will achieve all of these benefits. If you take that approach to your implementation, so some implementation, especially in earlier or in older systems, where you have been using structured paper templates that you have been using for your documentation, and then you introduce the first version of your IT system, you would be able to see a structure that really fully aligned with the paper you were using before. And that really supports recognizability and adaptability from the clinical perspective, because it was familiar to them, but that approach does not support interoperability and reuse of data. Because if you can imagine 10 different kinds of forms that are used for data entry and are structured in different ways, if we just plug electricity to that, then we still don't have the ability to interoperate between them. So in order to actually support interoperability and secondary uses, we need to consider standards. So we need a standardized approach to actually achieve some of the potential benefits of digitalization. So this is where terminology and the information model plays a huge role. There are many areas where you can standardize, but in the focus of this presentation, we'll cover the terminology and information model, because we'll cover terminology binding, all about what different kinds of architectural frameworks and the kinds of solutions you are using for your technology implementation and for security. Those kinds of things are, of course, also important to standardize. But here we are looking at the standards you can use to support a standardized approach to terminology and information models. The role of the terminology is that it functions as a vocabulary. And in general, a terminology is a library of terms or vocabulary that is associated with a certain field of study or a profession or activity. So a clinical terminology, it serves to provide a systemized and controlled vocabulary of clinical relevant phrases that can be used during data entry to provide a more precise and shareable expression that might be obtained by using free text. So that's a terminology. The role of the information model is to model managed objects at a conceptual level, independent of any specific protocols used to transport the data. So the role of the terminology is to serve as the vocabulary where the models are to represent the objects that are used. Very, very brief introduction to SNOMED as the terminology of focus here. SNOMED is a knowledge graph. It consists of 350,000 unique clinical concepts, active concepts, that are linked together via a set of semantic relationships. And those who attended the introduction, I know you are completely up to date with these semantic relationships. And for each of these concepts, we associate them with a set of descriptions. And an example you will see here where one code, so the concept, myocardial infarction, can have terms in English, in Danish, Dutch, in any country or language you want. And this concept represents a clinical idea. In this case, it's heart attack. And it's defined as being a type of ischemic heart disease, a type of myocardial necrosis. It has an associated morphology of infarct and a finding site of cardiac muscle. So within the knowledge graph, SNOMED CT, all of this clinical knowledge is explicitly represented. And we also have aside from being a knowledge graph, it's also a polyhierarchy. So we have these 19 top-level hierarchies where each of the concepts are divided by type, depending on the certain domain. So if it's a clinical finding or a disorder, you will go in the clinical finding hierarchy. If it's a procedure, you will go into the procedure hierarchy, and so forth. And this broad scope of SNOMED CT with all these concepts and all these hierarchies are really to satisfy the requirements for clinical professionals. None mentioned, none forgotten, because it is intended to fit the requirements of any kind of profession within the healthcare industry. And for clinical care and documentation, it can be things like signs and symptoms, test results, observations, diagnoses, procedures, abilities, and many more kinds of information. And this is really why we have such a broad scope of SNOMED CT. So that was the crash course to SNOMED. And now let's look at information models. An information model, if we just think a bit about that term, a model of information. There are many different kinds of models of information, and it can be, I think, every time the word information model is mentioned, there will be just as many understandings of that as we are people here in the room, because we have a certain experience and a certain field of interest, and we think about a certain information model. But if we just try to agree on some joint understanding of these information model, is the fact that information model is like an umbrella of different models that are used for different areas within any kind of information system or environment. So here you have some examples of models. So you can see there are information models that support the data entry and storage and retrieval. There are models designed to support interoperability based on shared definitions. There are models that can be used to discover knowledge from clinical data, models used to support evidence-based care, and there are also models to support shared content definitions. So on the left-hand side, you'll see some of the core models, models of use and models of meaning. So the models of meanings will often be, well, that kind of information model could be like a dictionary that you have in a country where you say, well, these are the concepts that we use in our country. So maybe we have a data dictionary, a dictionary of the terms that we use for rare diseases and we want to report, or maybe we have a model for use within some children's program. There can be many different regional, national, international clinical models where we try to conform or align what we do within a region. And the way they are represented is not defined here. It's just a model and it's probably very proprietary. The models of use can be a user interface model. So if you are in a software development company and you are designing user interfaces, the model you will use to construct these interfaces will be an information model for the user interface design. And then how you store what kind of data storage structure you use will also have a model around it. So when you design like a relational data storage model, well, then that's also a kind of information model. And on the other side, you see such things as data warehouse models, so specific models that are used to ensure that you can easily make specific kinds of data queries and analytics. And for knowledge models, it's the information models and rules you use when you apply and enable decision support, for example. And the last one is the communication models, and that is the one we're going to dive into now. So when we talk about interoperability, it's about sharing between organization, potentially organization that uses all these different kinds of models. So the communication models is really to ensure that we have a shared model for how we communicate and exchange information. And one of the models that we're going to dive into is message model, and a very well-known one and very widely implemented these years are the FHIR standard. So let's have a look at that. And remember, this is an example of an information model. So it could also look differently, but this is just an example. So within FHIR, they model how different resources that are used within healthcare can be represented. And going back to the original definition, it's the objects that we represent. So here we have a patient. So what are the things that are relevant to capture around a patient? It could be things like the name of the patient, the phone number, the gender of the patient, maybe the address, the marital status. So in FHIR, in this model, for that patient resource, these are the kinds of things that are stated that would be relevant to capture. Another resource used in FHIR is Another resource is the procedure resource, where you can see that some of the things, and this is a larger resource, there are more things here that could be relevant to capture in and around a procedure, such as the reason for the procedure, what was the actual procedure, is there any complication, or what encounter is it a part of? And you can see it's linked to another resource that is the performer or the device. So there are very many different attributes or elements that are important that are represented in the FHIR model for procedure. And here we have another one for conditions. So what are the things that are relevant to capture around a condition, such as severity of the condition, the body side, or when it was performed, or the status of the condition. So this is just to exemplify that the terminology looks at the individual codes that are relevant to capture in and around, and an information model creates these objects of things that may have different elements in them, because together that also provides like a combined piece of information that is useful to for understanding the situation, or in this case the message that you are trying to send. When we look into these information models, and when we look in FIRE, it's not only to say, well, these are the things that are relevant to include, it's also about how is it that we can represent these things. So here you can see this is the problem condition resource, and here you see that I have highlighted 4 of the different elements. So there is a category, a severity, a code, and a body side. So the code, and all of these have the type of codable concept. So it may be that that the type was a number. So if it was an object where you, or an element where you just stated a numeric number, but in these cases it's a codable concept. And every time you see that, that indicates that that's a place where you can use a standard coded vocabulary or terminology to represent the value. The code field is where that actual condition code is represented. The severity is where you would represent the code for the severity of that condition. And the body side is where you would represent the body side of the condition, naturally. And if you look at that body side one, you can see it over in the descriptions and constraints. You can see there is an example of what constraint that you can put here. And in this case, they suggest that it could be constrained to SNOMED body structures. So that is where we start to say, well, we have these things that are important for our object or our, in this case, problem. And these are the kinds of places where you can use terminology or a coded concept. And these are the concepts that you can use. And this is really where we start to talk about terminology binding. Let us just look a bit into an example of a resource. As you can see at the top here, it's a condition resource. And if we go down to the code part, where you can see there is a coding, that coding is the first part. You can see the system is SNOMED. There's a URI for SNOMED. So that URI, snomed.info/SCT, is how we represent the SNOMED code system. The code that we are representing here is the SNOMED identifier for ischemic stroke, where we have used the fully specified name as the display. But the text that was probably recorded in the user interface where this was captured and stored is probably just stroke, as you see it in the bottom there on the text. So each part code there has both the coding and a text, and that's why you see the 2 different types of terms. The display really comes from the terminology, where the text below is the thing that was displayed and stored. And that was where I wanted you to focus. Yeah, so now you know about the terminology and roughly about what an information model does. You have seen an example of information models, and especially messaging models. So the linkage, a terminology binding is really the linkage between the terminology and between the information model, because a meaningful health record requires that SNOMED CT is bound to the information models. So right now you saw FIRE, but if it was your local regional model for a certain domain, you would also need to properly bind it. If it was your user interface, you would also need to properly bind it, and so forth. You really need to perform terminology binding in many areas in order to implement SNOMED and in order to achieve those benefits. So depending on what your goals are, you really need to be careful on where you perform proper terminology binding. So let us look a bit more about the importance of terminology binding. So as I will show you very soon, users will gain benefits from terminology binding by achieving faster and more accurate data input. SNOMED CT is so large that if you just give clinicians access to the full SNOMED CT, it will be very difficult to navigate and find the proper concept, and it will definitely take a long time. So it's important to do proper terminology binding to support accurate and easy data input. The quality of your data will be better because if you do proper terminology binding, because the likelihood of you recording the type of concept that you really want to represent is increased. And of course, interoperability, because data can then be transformed between different information models that have the similar bindings. So why is this difficult? From the example I just showed you, it seemed very straightforward, right? That you have an element and you then apply a binding. But the challenge in terminology binding lies in the overlap between information models and terminology, where the terminology is very good at representing the instances, the different kinds of items and ideas we want to represent, such as diseases and symptoms, procedures. The information model is better at representing the contextual factors about the who and when and where, such as the dates, the times, durations, quantities, the peoples, the organization, things that you wouldn't put into a standard. But then there is a great overlap, because especially for contextual information, there is an overlap. So situations, when we want to say, well, I had a replacement of the right hip, okay, then we have a SNOMED concept that both include the body structure and the laterality. So do we need one data element or do we need three? So you can see where the information model sometimes wants to separate things, the terminology may include that thing, all the meaning within a single code, and that makes it can it make it challenging to then obtain consistency. And another thing that complicates is and makes working with context difficult is the fact that in SNOMED, as you've seen, with these concepts, let's consider a concept such as breast cancer. And that meaning of breast cancer can actually be altered depending on the context in which it is used. So here you have an example where the concept breast cancer is applied in 3 different scenarios. So if you record the concept breast cancer in a data entry panel for entering family history, then you are using that concept to state, well, this breast cancer is actually applying to a member of the family. So someone in this patient's family had breast cancer in the past. If it is recorded in a medical history area, then you're indicating that the patient does not currently have breast cancer, but they had it in the past. If you record breast cancer in a control for current diagnosis, well, then you indicate that the patient currently has breast cancer. And this is quite clinically relevant, right? This contextual information. Yeah, it's good that we can understand that there's something going on with the breast cancer, but the context is nevertheless equally important, that we know, is it the actual patient, is it going on now, or is it someone in the family? So context can be challenging. And another thing that makes it challenging is the way that we use different information models. I just showed you that web of different kinds of information models, and they are not all aligned, unfortunately. So here you have 3 different user interface information models. In the first one, we just have one field within a section for family history, and this is where we can record breast cancer. But we know that we are recording in a family history section, so that is implied by this information model. In the other one, we just have an input field, and here we can use the SNOMED concept for family history of breast cancer. So I can still express the same meaning, but here I use just a SNOMED code to do that. In the third system, we have 2 fields. We don't have an explicit context surrounding it, but we have 2 fields, one for documenting the disorder and the other one for recording the subject relationship. We are expressing the same meaning, the fact that there is a breast cancer and it's a family history because it's a person in the family who has this. So this is an example of 3 different ways of recording the same information. So if I just go back, here we are using the same concept in 3 different contexts. Here we are representing the same clinical concept or clinical meaning, but we are recording it in different ways. Okay, so why do we need to care about this? Well, in order to obtain interoperability, this is essential, because if I am recording and using breast cancer and recording that in a section on family history, but what I'm sending to another system is the SNOMED code, and they only understand the SNOMED code, then they will actually understand the fact that probably this patient has a breast cancer, because the surrounding context is not communicated in an appropriate manner. So the receiver wouldn't understand that, well, it's not the patient, it's someone in the patient's family. And this is really why we need to have shared communication models, so that we are able to understand and make sure that all the information that is required to properly interpret the meaning is included in the message. So let's now, do any of you have questions to this? Then I'll continue to talk about the principles for terminology binding. There are some very high level or general principles, and that goes back to thinking about the different types of information that we are capturing and the hierarchies of SNOMED CT. So the hierarchies is constructed in a way that they are by domain. So that means that if you are recording things like a diagnosis, a finding, a result, you would use concepts in the clinical finding hierarchy. If you are capturing things such as procedures, tests, care and therapy procedures, or follow-ups, you would use concepts from the procedure hierarchy. So this is very high level. If you are capturing social circumstances, you would look in the social context. And this is very high level, and it seems easy, but it is really, really, really important, because if you give access to the whole of SNOMED, you may have a good terminology, but you will have very inconsistent use of the terminology, and that will be poor data quality. So this, even though it seems very logical, it's really, really an important point. When we talk about terminology binding, there are two types. There's a type called value set binding and meaning binding. So here you see an information model to record a fracture. And that in this information model, the fracture can be represented by the type of fracture and the location of the fracture. So the value set binding is about representing the values that each data element can have. So for example, the type element in the model can have a linkage to a value set, and that value set can be represented by SNOMED codes. It can also be other codes, but in this example, we are at a SNOMED conference. We are looking at SNOMED value sets. So here you can see there is a value set consisting of 4 different types of fractures: displaced, undisplaced, open, and closed. So if we constrain that type field to these 4, we make sure that we are not using other concepts from SNOMED that are not relevant to capture in this case. And that goes back to my talk about making it fast and easy and accurate. So linking each of these elements to certain concepts that are relevant is what we call value set binding. The meaning binding is where we actually say something about what the meaning of the model is. So in this case, we have a fracture information model. So because we have bound that whole model to fracture of bone in this case, we know that the context, it tells us something about the context of this model, that it's about a fracture of bone. And when you know about the concept model for SNOMED CT and how we model concepts, we can actually use the concept model to help us perform the model meaning binding for each of the different types of data elements. So if you know that the type of fracture, if you understand the concept model and knows that the associated morphology is what we use to represent the morphology or the type of fracture, well then you can easily derive the value set that you need, because there are certain morphologies that applies to fractures, and then you can derive that value set. So this overview gives you an idea about what we mean what I mean when I say value set binding. It's the actual values that you can apply, and the meaning binding is about representing what does this model mean for data entry. So clinicians entering clinical data, they are seeing the values in the value sets. They don't see anything about the model meaning binding, the meaning bindings. That's really something that is for implementers, and that helps us to control our models and utilize the models and utilize the terminology to accurately present and use the terminology within our models. Oh, I think there's a lot of animations coming up here. I'll just walk through them. Okay, so these value sets is what, if we are thinking about a user interface model, is really what's behind the data entry controls. And when you define the value set, so now you just saw those 4 type values, but actually when you define what a value set consists of, you can do it in 2 ways. You can define them by a rule, or you can define them manually. If you do it by a rule, it could be things like saying, well, I want all of the concepts that are respiratory diseases, or I want all the different kinds of procedures done by a certain method. So you simply specify a rule. And if you define them manually, it's simply picking the things that you find are valid values for that field. And again, SNOMED CT hierarchies can help you to these things. So for example, if you have a diagnosis field, well, you know you need to constrain to types of diseases. If you have a procedure field, well, then constrain to types of procedures. And you can be even more refined. So if you have a field for allergic conditions, well, then you maybe want to refine to only things that are types of allergic condition, so that you take away all the noise that would be by just browsing the entire SNOMED. And is this really important? Yes, it is. In 2014, just in the early stage of the national implementation of SNOMED in the UK, they actually attempted at an emergency department to give clinicians access to the whole of SNOMED when recording the reason for encounter or the reason for being admitted to that emergency department. And although this is now a 10-year-old study, it is really illustrative in why terminology binding is important. Because if you just give a clinician who has been very well trained and are very clever and with a good clinical knowledge access to a browser to the whole of SNOMED, of course, if you get a patient who maybe have a fever, you would type something with temperature into the field. Or maybe you have someone who is have an alcohol intoxication or something, then you will search for alcohol and you'll get things back, and it will look like it's a good result, and you'll just pick it. And we know how fast and how little time they have to do documentation, so they don't have the time to go and explore the defining properties and make sure that that concept is in the right place of the hierarchy. They really need to just see the things that actually is what they are looking for. And you can see here that almost 1,100 times, so 1,097 times, there was a search on temperature, resulting in the capture of an attribute that we have for temperature. So it's not really a finding of anything. It's something that is a metadata concept that can be used to link two concepts. Or another thing, if it's a fever, maybe they have refined their search, maybe they wrote high temperature. But we also have a concept for high temperature, but in SNOMED, high temperature matches a physical force. So if we had a higher temperature in this room, which would be good, right? Then that would probably be what we would be using, but it's not an increased body temperature, right? So another one is the alcohol one, where it's the substance that have been recorded and not the actual alcohol intoxication. And this is what I mean when I say, yeah, we may well have a high quality terminology where lot of thoughts has gone into the modeling and making sure that everything can be inferred correctly and so forth. But this is really one of the devils in the implementation, is that you make sure that you apply it correctly, and that you make sure that clinicians don't go and do that, because it's not their intended meaning is not what is being recorded from a terminological perspective. So how do you implement? So it requires you to have good subsets. So supporting data entry and supporting terminology binding is really about creating good subsets. So let's talk a bit about subsets. A subset, as defined in mathematics, is a group of things, is a smaller group of things that belong to a larger group of things. And in SNOMED, you can have a subset that consists of SNOMED CT identifiers that points into some place in the terminology. And the use cases are to constrain data entry, as we've just been talking about. It can be used to support communication. What are the things we want to communicate? It can be used for data analytics and reporting. So what are the things we want to count and analyze? And a value set, a subset is used, can be used as a value set. So a value set is really, when we talk about terminology binding, the set of concepts that apply as the value for a specific data element. And a subset of codes can perform as a value set. And as I said earlier, it doesn't have to be only SNOMED. You can have a value set that consists of codes from different code systems. Within the binding, it then needs to be very clear where the source of the code is so that it can be resolved. And this is an example of a binding of from a medication order information model where there is a route data element, and there you can see some different routes that have been derived and performs as the value set. So that is the manual way of creating a subset where you simply go in and pick these are the members you want, but you can also do it using a query. So where we want to say, well, I want all the surgical procedures to be acceptable for this data element, or I want all disorders with a morphology of inflammation. So we can be very specific about what kinds of concepts you need. And this often results in some larger value sets. And you can use expression constraints, using the expression constraint language to produce these. So the expression constraint language is a computable rule that you can define to retrieve a set of clinical meanings. It has many features, but actually the top two there, or the descendants of, are probably the ones that are very powerful when it comes to terminology binding and want to specify, or maybe you want to add a simple refinement. If you want to learn more, you can access the guide here. Here is an example of a simple expression constraint. So this expression constraint will be satisfied by all concepts in SNOMED that are subtypes of excision of appendix. And in the SNOMED CT browser, you can actually execute these expression constraints. So here you can see that there are 12 different types of excision of appendix. You can create more refined, as I said. So here we have all the diseases in SNOMED, so all the descendants of disease, but the diseases we are interested in are only those diseases that have been defined with an associated morphology equal to fracture or any kind of fracture. And as you can see here, that produced 2276 in the version where it was executed against. So here you can see, when you look, this is a concept that would be satisfied by that expression constraint, so that would be included in the expansion or in the result. And here you can see fracture of tibia has been defined with an associated morphology of fracture, and that's why that is included here. Another one here is a disease with a finding site that is equal to any kind of bone structure of tibia with an associated morphology equal to any kind of fracture. So that's an even more complex expression constraint. But what we get there are those diseases where they have a finding site, where the finding site is any kind of bone structure of tibia and any kind of fracture morphology. Okay, I thought I would get before an overview of the expansion. So my test to you is for you to take this expression constraint and pop it into the browser, and you can see how many we have of those. I could actually maybe spend just a moment to show you, those of you who are not familiar with expression constraint language. Let me go into the browser. It's not loading. Okay, maybe we are not doing this now. It is slow. Maybe many people are going into the browser these days. Okay. Now I'm in. What was it? Disease. I'll just copy it. Woo. So in the browser, you can go to the expression constraints tab, and I'll enter this expression constraint. We actually do have an ECL builder, so you can go and explore that. So you don't need to know all the syntax. The builder will help build it. But what I'll do here is just to click execute. And as we just learned, it's slow today. So what this language does is actually looking at the defining properties of the concepts and make sure that it retrieves all the concept that is defined matching these. So now you can see that we found 96 concepts that matches this expression constraint. And if you go in, if you click here, you will be taken into the definition of these concepts, and you will see that the fracture is not only those that are defined with a fracture, but some of them will have be an open fracture or closed fracture. There will be different kinds of morphologies that will be represented, because we are actually saying that we allow any kinds of fractures to be retrieved. One point I would like to say here is now we get 96, but if we go back in time, that's something we can, in SNOMED, we can jump in time. So let's jump back to March of 23 and see if something had happened with the hierarchy since then. This is also an extension of the points I made in the first session, that it gradually evolves sometimes. So you can't always say that, is this the right number of concepts? Well, it will depend on the substrate. And right now we're using the international edition. If I was using another edition, then I would get a different result. So here you can see we have 83. So some concepts have been added, but we can't conclude that 10 have been added, because some may also have been inactivated in that hierarchy. So this will just making the point that when you perform terminology binding, and especially if you're doing, it's just good practice to also show what version of the concept. It will help to resolve the concept, that you know where it's from. Okay, so that was a bit about expression constraints. Another feature of the expression constraint, so we have also talked about subsets, and in SNOMED we represent these subsets as simple reference sets. So you can actually also create a subset that you represent as a reference set, and the expression constraint language allows you to then say, well, give me all the members of this reference set. And that's also useful for terminology binding. So if you say, well, in this case, we have a nursing activities reference set. So if you are in a nursing part of a journal, then you may have what is the activity that has been performed. Well, then you look up all the things that are available in the activity reference set. Yeah, I'm not going back to the browser, but if I were, we have a nursing reference set there, and then you would see if I ran this ECL, then we could find all the members of a reference set. So that is the basic principle for terminology binding, is that you create some good subsets, and whether you do it manually or whether you specify it by your subset by a rule, it's really all about creating those good value sets. And what is a good value set? Well, that's what the next part is about. A good value set is one that accommodate your information model. So in order to create a good value set, you need to know what are the data elements where it's going to be used, and what are the surrounding data elements, because that's not unimportant, and I'll show you why in a second. You need to understand how it's going to be used, and you need to ensure that the concepts reflect the meaning that you are wanting to represent. So about knowing what data elements are included in your information model is what this is about. So here you see there are two different fracture information models. Again, we've seen the other one before with the type, body side, laterality. But in another information model, it's very simple. There are some systems that are being implemented that have very, very simple models where you only have maybe one field for a thing. And that would be what you see in the image to the right. And it's different what kinds of value sets that you would apply in these cases. So over in the more simple one, you can actually go into SNOMED and you can even define something like all the descendants of fracture of bone. And all the concepts that you could get there could fit in here, because it's just specifying what is the type of fracture that you're representing. Is it a fracture of humerus? Is it a closed fracture of hip? It could be anything. In the other information model, we have separated the information more. So one way we specify this is a type, this is a body side, and this is a laterality. So maybe in the body side where you can say, okay, what are all the bone structures that can be fractured? So that's where we actually specify the body structures. And the body type set, you then need to make sure that you are not overlapping. So here you can see the fracture type. We actually have fracture of humerus, closed fracture of hip, and open fracture of bone. So if I was applying these two value sets and my system was not clever enough to have some logic between my elements, I could actually record fracture of humerus with a bone structure of femur, right? So that would be very undesirable, right? Because it would really be difficult to interpret what I meant. So if you are applying this kind of terminology binding, you need to ensure that there is some logic, so that if you are entering fracture of humerus, then you also derive automatically that it's the bone structure of humerus that you want to represent. And that could be done logically. SNOMED will give you that, because the SNOMED concept fracture of humerus is defined with the finding site of the bone structure of humerus. So the system could be set up so that it populates automatically. And that would be great. Then you can use this approach. But if your system is not set up with that kind of logic, then you need to be, okay, I could hear myself. Good. So then you need to be more specific on how you create your fracture subset. Here's another example. If you then entered closed fracture of hip and you entered bone structure of radius, that wouldn't be very good. So you need to use that logic to avoid the redundancy. Instead, you could then say, well, in my type field, I'm only representing those types, the different types of fractures that don't have a body side or a morphology specified, if you don't have the logic between them. And you can derive that using an ECL as well. Say, give me all the fractures that don't have a morphology and don't have a body side. And then you'll have the remaining concepts being concepts that are likely to be relevant for this field. And then in the body side, well, then you can have all the different kinds of bone structures and so forth. Yeah. So this is really just to say, this is why the different or the surrounding data elements are important. So this is also about ensuring that your subset reflects the intended clinical meaning. If you look up concepts in the browser, such as blood pressure, you'll see there are many different kinds of blood pressure concepts. Some is a finding, some are procedures, and others are observations. And you really need to be careful that you are in the right place in the hierarchy. So if you want to record actually the result of a blood pressure taken, if you want to record the procedure, apparently, then you need to make sure that it's a procedure concept, because the findings will be the result of the procedure, blood pressure procedure, and the observation is just to state that you are observing the patient's blood pressure. But the action of actually doing is in the procedure hierarchy. Another thing is about avoid including grouper concepts. And this principle only applies for very small concepts. So when you manually pick maybe a list of 10 concepts for your value set, there are some concepts in SNOMED that are not intended for clinical documentation, even within the finding hierarchy, for example. So for example, if you are picking a list of different abilities to eat, so you can see there are many concepts that are finding related to ability to eat or ability to drink. And that concept in itself doesn't tell us whether the patient is able or not, right? So that concept would not be relevant to have in a pick list. You need to go down and being able to say, so for example, here you can see the subtypes of these concepts. The subtype of finding related to ability to chew, you'll find, is the patient able to chew? There's difficulty chewing. The patient does chew, does not, or is unable to. So it's important that your value set consists of members that have that level of detail, so that you actually represent the actual result and not just what it's about. And these concepts are very important in SNOMED. They support navigation and grouping the concepts, but they are more abstract in the sense that they don't represent the actual result of an observation. This is like a cheat sheet that my good colleague has created. It helps those that are doing terminology binding in actually seeing where, if you are creating value sets for a problem list or a visit diagnosis or results, you can see, then you would go to the clinical finding hierarchy. If you are, all the greens ones have like very direct clinical usage or usages in the information model. The yellow ones are hierarchies that needs to be used in the context of something else. So for example, the body structure hierarchy you would use if you're refining a clinical finding or procedure. For example, as we saw, what is the procedure, what is the body side of this procedure? Then you would use body structures. But body structures in their own right doesn't give a clinical enough context to be able to interpret it. I'll show you an example of that. And the red ones, the red hierarchies over there, are really concepts that you should not bother about at all when you do terminology binding. So please just always omit those. Especially the last hierarchy, the SNOMED model component model hierarchy, is where you'll find all the different kinds of attribute types, or you would find the different reference set concepts. So that's metadata that are used to support the representation of SNOMED. As you can see, we represent everything through concepts, also the metadata, and the metadata is not for clinical data entry. So please refer back to this sheet. It's really a good pointer to what are the things we're trying to represent, where should we look in SNOMED. Oh, there are many. I'll just jump through these animations. Yeah, so there is there is a note that I need to make here. So for clinical findings and procedures, and this goes back to the point I made in the beginning. So if you're using these concepts in the context of maybe family history or something else, you need that concept model awareness that we were talking about just before. Those yellow hierarchies that are dependent, that not in their own right helps you to make a conclusion on a certain situation, is exemplified here. So for example, in a dermatology clinic, imagine that you have a diagnosis field in your record and you then type elbow, right? What does that mean? You know the context is a dermatology clinic, so something with the elbow, right? But it doesn't tell you what's wrong. Or if you were using the qualifier mild, so okay, you know that there is a mild diagnosis, but you have no clue. So mild elbow, that comes from the qualifier and the body structure hierarchy respectively. You need some more information to be able to understand these what they mean. So now you see that if we apply a diagnosis to these, and we so assign the diagnosis dry skin, and we still have the elbow body structure, or we have maybe refined it to the skin structure of elbow, and we have also applied a severity. So first of all, if we look at the body side and the severity, we are now saying what the concept actually represents, that it represents a severity and that it represents a body side. But now we also know that it refines the diagnosis, which in this case is dry skin. And now we are able to conclude that the patient that this is about has dry skin on the elbow in a mild stage. So this just shows why these yellow hierarchies are very valuable, because they are helpful to really clarify the meaning that we are trying to represent in one of the main hierarchies, such as disorders and procedures. And this leads me into the concept model. I don't expect you to be able to read this. This is an overview where you see all of the different attributes that can be applied to disorders. So when we define clinical finding concepts, we can't apply any kinds of relationship types, but we can apply these, and we can then, the values that we can provide are also represented, and you can see it here. It's using the expression constraint language to say these are the types of concepts that you can use. And the reason I'm showing you this in the context of terminology binding, so if you think about that example with the diagnosis, the severity, and the body side, you can see that this is a concept model for diagnosis. And if I look at severity, it's in the bottom here. Here, look. So for a diagnosis or for a clinical finding, I can apply a severity attribute. So if I were to create a concept in SNOMED, I could actually state whether it was what kind of severity it has. We only recommend that in the context of extensions or post-coordination, but it can be done. And the values that you can use to represent a severity are all the descendants of severities in the qualifier value hierarchy. So the concept model, all these rules are useful to identify the concepts that can be used for certain as value set values for certain types. The same for the body side one. We have finding side, and all the concepts that can be used as values there, you can see by this rule in the concept model, which is the anatomical and acquired body structure. All right? So this is why the concept model can actually assist not only authors, but also implementers in how to do binding. You can notice that I'm not that familiar with these animations, but yeah. So when you go in and use these expression constraints that are available in the machine-readable concept model, you can actually find those concepts that can be used as values. And this is how you can do it. So here, those rules are documented in the editorial guide. So all the rules, we have a document, it's available so that you can look at these rules. We also have a machine-readable concept model so that we are able to validate when codes or concepts are authored, but also where you can go and have a look and see what are acceptable values. If you go into the MRCM browser, you will be able to see what are, if I'm in this example, I have entered the clinical finding, and then you'll see all those attributes that was just illustrated in the table just before, and you will also be able to see the ranges. If you have any questions, please just let me know as we go along. And you can also see the values for those ranges. So this is a very good browser for actually looking and exploring the concept model. And this is just to show how it actually links to terminology binding. So here we have a condition resource. The code is a code from the clinical finding hierarchy. All right. So that is what we will put into the diagnosis field. Then we also have a severity, and that is the values for that would come from the severity area. and the body side would come from the anatomical and acquired body structure hierarchy. So this really shows how the information model that you have specified, you can align it to SNOMED CT, and you can use the concept model to make sure that the binding that you're performing is not only consistent with your information model, but it's also consistent with how we model concepts in SNOMED. And that may seem like a very large piece of work when you do it, but I can assure you it will pay off when you've done it, because these principles can be pretty stable, and it will help you when you then want to derive data afterwards and want to share it. I want to show you some examples. The user interface demonstration, I'm not going to spend so much time on because I've already showed it once today, and I think for some of you that are in here, and those who weren't in here before, I can see that many of you I know have seen it before. But we have a user interface demonstration, and terminology binding is really what goes on when we constrain a field to a certain part of the terminology, clinical finding. And here you have the procedure, which has been bound to all the procedure concepts. So this does so that I can't, for example, if I type asthma in the procedure field, yeah, and it's pretty slow. You can see the things that I get back are not actual conditions of asthma. I'm only getting asthma procedures in the result. In the diagnosis field, if I type asthma, I will get some asthma conditions, because here we are excluding all the procedures. So this is really to show why terminology binding is important from a data input side. And I also want to spend some time on the demonstrator. I don't know if we should do it now or run into these. Yeah, maybe we should show that now. And then we can, if we have time, look at these examples. We have a few examples here at the end. But I think because we have a demonstrator, we have a tool that you can also use when you want to try and perform terminology binding. Alejandro can just show you that now. I need to stop share. Yeah.
Thank you. Okay, this is a demonstrator of terminology bindings. It's like a sandbox that allows you to play with these ideas that Anne described. It will work very slow today. Sorry about that, but it looks like we are all doing this kind of demos and we are overloading the server. But basically, you can load an example to see how it looks like. And this is an example of different types of fields that can be configured. So you can search things, for example, some kinds of appendicitis and things like that. So what I will show you how you can create this using this tool. We'll clear, and you can create a new binding, for example. So let's say the first question is the reason for encounter. Let's say reason for encounter. If I want, I can add a question code here. Yes, and that's the meaning binding that Anne was showing. Mm-hmm. Maybe we have a reason for encounter question code. You can restrict the search to observables. Yes. So you're configuring what's the code of the left of the question itself and what's the code of the right, which is the answers, the possible answers.
Just do the values.
Yeah, let's do the values that binding is easier. So I will say this. Let's make it this an autocomplete, and I can open the ECL builder to say, okay, let's use the descendants of clinical finding. Yes. So let's wait until it loads. Clinical finding. Okay, good. And this is my first field will be that I click add binding, and now my form. Let's say demo. Can change the name. Demo data entry form with bindings. Yes, and I have my first field here. And I can type here something like asthma, and it will search following the restriction, asthma, asthma cause, asthma mild, yes? And I can add like a second field, like the procedure, and I can say that the answer type is let's say I have 3 procedures, or maybe like a blood measurement procedure or something like that. So let's do like a select, yes, a select control, and let's look for some procedure that doesn't have a lot of blood pressure. Oh, this is not searching, sorry. I need to do the ECL. I can do self, let's say.
If you have constructed an ECL in, for example, the browser, you can copy it in and you can put it in the text.
Yeah, you can put it there as a blood pressure procedure. Consider taking, and let's add one more. Add not a refinement, let's add another focus concept with an or, and let's say self, and let's do another thing that you can do, like temperature. I missed an E there.
There's something with the spelling, I think. Body temperature.
Let's put another measurement procedure in general. It's a bit slow.
No, it's very slow.
Yeah. There are many procedures and many people trying to find things in the server. So let's do one like pH. This is not the right thing, but lead measurement. Yes, and you have 2 procedures there with an or, and this is the ECL that I can paste from somewhere else. And this is a select. So, or maybe we can do like an options, maybe because there are only 2, and I do add binding. Yes, and the binding is there. So now I can type asthma here, and I do a blood pressure measurement. Yes, and I can open the data panel, and I can see how the information is collected. And this is like a simulation. Yes, so when I change the value, the collected information also changes. And I can see it as a simple collection or as a file bundle with observations. Yes, or I can see it as a fire questionnaire that you can download and upload somewhere else.
So, Alejandro, create a field for me where I can search for only food allergies.
Exactly. And this is something that I don't know if you mentioned, that depending on the size, on the number of options, you could choose different controls. And because food allergies are many possible options, we will use the autocomplete. So you type something and you filter the food allergies.
So when he did the first binding to disorders, that would also include all the food allergies, right? But in some situations, you may only want to look at those concepts that are food allergies because the model you're working with is constrained to that. And that's just to say that there's no right or wrong answer, right? Or that it is for a specific situation, there is. But that's why we can't generalize. You always have to do this, you always have to do it in this way. But you really just have to think carefully about your usage situation.
So we have, for example, allergy to fish oil. Yeah, so you can type just the name. In this case, because it's restricted, you can type the name of the food, like milk, and you will only see food allergies. What do you mean?
Oh, that's good. Can you show
Allergy to cow's milk protein.
that you can see the bindings in the eye?
And when you click on the eye, you can see the binding of the field. Yes, and this is a mixture between exercising the bindings, but also exercising good practices for UI. And this is how you can change to different things. For example, options, you can change this to a select single and update the binding. And now if we go back, instead of having an option, you can click here and you will have the same 2 options, yes, to select from. And if you change to a multiple selection field, it will be similar. So this is more, or checkbox, for example, checkbox multiple.
So how can you use this? Well, you can create a form. So for example, if you're sitting When I did some implementations in Denmark, I did it with nurses, and in order to make them, it was in the early stage where you have to like convince them that this is that there are terms in SNOMED that can match your need. So having a thing like this, you could build it up, and you could have them actually see how it would look, and they could do search for some scenarios. So this is a good, like, in the stage of implementation to actually discuss it with them. So this thing that Alejandro created, you can download it and store it on your machine, and then you can upload it again. So the system doesn't store it for you, but you can create it and have it on your local machine, and then when you need to use it again, you can upload it and use it. So it's your own thing.
And you can go and play around with this. So if you go to the implementation portal, showcase demonstrators, you have the whole list of demonstrators here. Yes, and you can click on the sandbox. Terminology binding sandbox. You click open, and it's open inside this box to play around. Yes, and you can work with this.
So don't be afraid of breaking it or anything. You should really just use it as a playground and do all sorts of good terminology binding there. We have 15 minutes, and I know I'm not going to go through all the slides, but I definitely want to just take you through one example, because then when you see when you get the slides, you will see the next examples, and hopefully they will be self-explanatory. So this is about allergies. So now we've just looked at the allergies. So you can have many kinds of allergies.
You need to share the screen again.
Oh, yeah, I need to share.
Yeah.
Good.
That's a beautiful slide.
Yeah, it's a beautiful
Not
slide.
to show it.
You're right. And beautiful kids as well there. Good. Well. So I was showing this beautiful slides. So this example is about allergies. So let's consider being allergic to a shellfish. And how is it you would record being allergic to shellfish? Will you record shellfish, the organism, or will you record that you need shellfish-free diet, or that you have an allergy to shellfish, or just shellfish, the substance? There are many shellfish concepts in SNOMED. And so what is it that is relevant to record? And that actually depends. And this is where there isn't a single correct answer, because it depends on your model. So in one situation, you may have decided that what's important for us is that we record the cause of the allergy, not the actual condition, because as soon as you have recorded something here, we know that you have an allergy. We just want to know the thing that you're allergic to. Well, in that case, the substance would be relevant to record. In another model or in another implementation, they may have decided to actually record the condition. And in that case, well, then you would need the allergy to shellfish. So really understand the context of use when you perform the terminology binding. And actually, it doesn't matter that much whether you go with one approach or the other. You will still be able to interoperate between models that do take these approaches. And the reason why that is because you're using a terminology that is defined in the way SNOMED does. And that speaks to the point I was talking about this morning as well, about the quality of SNOMED and the quality that lies in having defining properties. So the condition, allergy to shellfish, is defined as being a type of allergy to seafood, and it has some defining properties, that is that it has a realization, which is an allergic process, and it has a causative agent of shellfish, the substance. So you can see, in one case, I was using this concept, and in the other, I was using this. So if I'm recording allergy to shellfish in my system, I can actually derive what is the substance you're allergic to. If I know I'm communicating the cause of an allergic condition, I can derive the condition from knowing what the causative agent is. So you can see we can have two systems that actually use different kinds of approaches, but understanding what approach was taken will actually help us to transform between the two systems that apply different approaches. And in the demonstrators section that Alejandro was just showing, you will also see that there is an allergy demonstrator, and that demonstrator will show how you can swap between using the propensity to adverse reaction hierarchy or using the substance hierarchy for recording. And when you go into that demonstrator, really look at the fire response. Is it yeah, I think it's a fire response that is produced there, and you can see how the different codes changes regardless, and the substance will retain the same. Here's the link for that. We don't have time for that now. Do we have a few minutes for the malignant melanoma example? This is the same principle as before. When you're recording it, are you recording the morphology? Are you recording the actual diagnosis, the situation? What concept are you using? So in a histopathology report, well, then you would want to record the morphologic abnormal structure, because that's not where you record the actual diagnosis. That is where you record the result of the test, and that is really what is the abnormal structure that has been identified. In this case, it could be a malignant melanoma morphology. So the diagnosis that the patient would have, if that is the context you're recording it, well, then you would use the disorder concept. And in this case, it could be a concept such as malignant melanoma of back. But if you have a model where you separate it, you may want to record just the disorder malignant melanoma, and in the body side field, you would then record, if it was the back, the body structure of the back. So what concepts you're using and what concepts you're binding to really you need to understand the context of use. And this was probably where I was handing over to you, if we were following the agenda. Yeah, we have some examples with the procedures and with context. So whether a procedure is performed now, if it's planned or stopped, if it's for diagnosis, if it relates to the history or if it's suspected or rejected. And those concepts all sit in the situations with explicit context hierarchy. So this is where we have used procedures and clinical findings, but we are altering their context by modifying some of these contextual factors. And there are some concepts in SNOMED CT where this is present. And here you see the concept model for these concepts. But this really allows us to using the SNOMED CT concepts to represent more complex clinical situations, such as the family history of epilepsy, where you actually use the disorder concept of epilepsy and you state that it relates to a person in the family. But it may just as well be that you have an information model where this is used, where you actually just record epilepsy and you could do it in a family history section of a model, and that would be just as well. But no understanding that the context is the family history will allow you to derive the situation as well, and that will also support the interoperability between the two. When you have suspected disorders, we have another attribute that allow you to specify suspected. So there are different of these defining properties that allows us to actually alter some of the meaning. So a planned cholecystectomy is not in the procedure hierarchy because it's not a true procedure yet, because it hasn't been performed. It's just being planned. Yeah, history of stuff. So look at these examples and look at how they can align to an information model. I'll just wing through them and confirm that I have reached the end, and we have a few minutes for questions if you have some. Mikael, you have some.
Yes.
What is actually your recommendations when it comes to the hierarchy situation with explicit context? Because it's a very tiny hierarchy, currently 5,010 concepts in it. So as soon as you would like to do anything serious, you run out into no available concept, as long as you're not doing post-coordinated expressions. And it also seems to be that hierarchy that screws up everything for people when they start to use SNOMED CT with information models, because you quite often see double negations, double family history, and all those kind of interesting but maybe not that useful stuff.
It's a good question. Thank you, Mikael. Well, this is something that Alejandro and I are discussing every week. We spend a lot of time of discussing what the recommendation is, and the common ground right now is that if you have the possibility to have an information model with the different data elements that can represent all the meaning you're trying to represent, then you should go with the denormalized approach, where you don't use situations at all and just use the information model. So that is the recommendation. But what we see in the team is also that many implementations need, because they have a more simplistic information model, they need to be able to express contextual factors using the situations. So although best practice is to hold that information in the information model, it cannot be a generalized rule. Do you want to add to that?
Yeah, another advantage of using the deconstructed form, so using the information model, is that you have more variety and better coverage, because there are not enough pre-coordinated situations like elements that you can use and combine to represent information in the information model. So you have better coverage in that way as well. If you can, I mean, that's the limitation, is if you are able to have, like Anna was saying, information model there. Yeah.
But this is why it's so simple. This is why we are not actively working on creating situations, because we add them when they are requested by our users. And we have an ongoing project right now that we have also been meeting this week, where we are talking about actually recommendations and way forwards for situations. Yeah. Are there other questions? Then you need a coffee break, right? All right. Well, enjoy the break, and see you later, hopefully, or enjoy the expo.
Thank you.
And to those of you online, thank you for attending. Reach out to us if you have any questions.